All right, Rupert Sheldrake, super excited to have you here chatting today. And yeah, thank you so much for joining me. There's a few things that I thought it'd be cool for us to discuss. So I'm going to go ahead and get the ball rolling on that. I know we do have a little bit of time restraint, but
Well, let me first say, Keelan,
go
that
ahead. Yeah.
how much I appreciate the work you've done so far. Your long exposition on morphic resonance is really one of the best out there. I mean, it's really well done. I mean, you've really gone into it, you've understood it, and you've expressed it and illustrated it very well. And I think some of your other videos, like how science became unscientific, and some of your stuff on Whitehead and Bergson, is extremely good. So I'm immensely impressed by what you've done.
Thank you so much. Thank you so much. And of course, your work obviously has been a huge influence on everything that I've been trying to do. So it's great to have you here. It really is. So but yeah, I wanted to actually kind of start off by talking about the problem of induction within science and the idea of laws of physics, physical constants, right? So the problem of induction goes at least to Hume, right? Hume uh, was really the first, as far as I know, to raise this issue of how we can rationally take what we actually have to work with empirically and then begin to extend beyond that into things that we can't see. How can we know that there is this uniformity to nature? And the way that that has been grounded within most modern scientific research has been through this idea of physical constants, quantifiable mathematical rules, which the world is believed to follow invariably. And of course, with these ideas of morphic resonance and ideas like Whiteheads and so forth, um, we really have to raise the possibility that these constants aren't actually constant, that they may be scale variant, that they might be evolutionary, that they may be developed over time throughout the course of cosmic evolution. And so, if that's the case, if we're really taking that possibility seriously, then it seems to me that that poses a problem for the very methodology of science, the basic presumptions of science, in that I feel we have to be presuming some kind of uniformity to nature in order to make any sort of inductive inferences at all. And so, in as a kind of alternative to that more standard viewpoint, I've been really looking at the works of Johann von Goethe and the way that he conceptualized science and the endeavor of science. One example of this, just very quickly to illustrate, um, when Goethe began studying biology, it was kind of a trope at the time within science, this idea that all mammals except for humans have the premaxillary bone, which is kind of a snout bone in the face, and it was believed that human beings do not have that, and that's what separates us from other animals. And Goethe learns about this as he's studying biology, and he is just having none of it. He's like, no, it can't be that way. That's just not how nature works. And he follows this intuition, and he starts thinking that maybe that premaxillary bone is there. He thinks it must be there, but maybe it is only present in like fetuses or infants before it fuses into the rest of the human skull structure. And he starts pursuing this, and lo and behold, he was correct. So this is very interesting because he did not have any data or experimental evidence or anything like that to inform that intuition. His intuition was purely on the basis of this idea that that's just not how nature works. There are these formative compositional, excuse me, formative compositional elements in life which can't simply be taken out or added to willy-nilly. They can be played with, but those basic elements have to stay there because they are what they are in relation to one another. So anyway, I'm bringing this all up to just kind of put that on the table and maybe talk about how that relates to these ideas about morphic resonance or just morphogenesis as a kind of scientific principle more generally.
Well, there are a lot of things here, Keelan. First, of course, Goethe didn't know about evolutionary theory, so it wasn't really an evolutionary theory of continuity between humans and other animals. But he did have the idea of kind of archetypes or forms or almost Platonic principles. And in fact, at that time, rational morphologists, a subject called rational morphology, thought of animal forms as variations on various archetypes. And so I suppose that's how he got to the idea about the intermaxillary bone. The There's a sense in which the scientific assumption that the laws of nature are fixed is in fact Platonic. It comes from the Platonic philosophy. It was built into science in the 17th century by scientists who took a kind of Platonic philosophy that the laws of nature are mathematical ideas in the mind of God. It's really a kind of Platonic theology. And since God is eternal and universal and omnipotent, these laws of nature share in these divine qualities, including immutability. They're just eternally changeless. And in fact, that's got built into the foundations of science. And that's the main problem I have in putting forward the idea of morphic resonance, where I'm saying that instead of fixed laws, the regularities of nature are more like habits. There's still regularities, and habits are regular, but they're just not fixed. And habits build up in time and get stronger through repetition. So after a lot of repetition, like the crystallization of sodium chloride or the formation of hydrogen atoms, things that have gone on for billions of years, the habits are so deep-seated that they behave as if they're governed by eternal laws. But that's why, to test morphic resonance, you have to look at new habits and study the way they build up. So I think when you were talking about the eternal fixed constants of nature, that's slightly different, of course, from the laws, because most scientists assume the laws are fixed, and they also assume that the so-called physical constants, like the gravitational constant, the speed of light, and so on, are also fixed. So I agree with the traditional view that Goethe started from, and which, in fact, all scientists start from, whether they're conventional or unconventional, of general principles that apply to all nature, that there's something we can generalize about nature. I mean, after all, cosmologists and astronomers generalize to the entire universe on the basis of things that are measured in laboratories here on Earth, which is a tiny part of the universe, much tinier than people used to think, because the universe itself is so much bigger than we used to think. I think there have to be, in order for science to proceed at all, there has to be the assumption of some kind of order or regularity in nature. But then the question is what kind of order, and my answer to that is, the habits rather than fixed laws. In relation to the so-called physical constants, my approach there is purely empirical. Are they really constant or aren't they? And the best way to find out is to look at the data. When one does that, then the data vary quite a bit, especially with the gravitational constant, big G. The usual assumption is that these are just errors, but there could be real fluctuations. But that, for me, is an empirical rather than a theoretical question.
Yeah, absolutely. And so then if we're beginning to think in terms of habits that build up over time, that does, I think, kind of implicate consciousness in some kind of way, because a habit, a repetition of one decision over another implies something like a teleology, I would say, that there is a striving there by which certain possibilities are being selected over others, which can then allow for these habits to then build up. And so looking back to the science of Goethe or even Newton, they were not really thinking in terms of a radically evolutionary cosmology, but they at least had the idea of God. But now it seems to me that if we are going to be thinking of a truly radically evolutionary universe in which the constants are habits, then there's a kind of necessary implication of some kind of underlying purposiveness, or an underlying striving or teleology or something like that, which is then kind of serving as the guiding light, which preconditions the possibility of these habits being built up to begin with.
I don't think that teleology necessarily implies consciousness.
Okay.
I may do in the creative act that gives rise to a new habit in the first place, but one of the features of habits is that through repetition they become unconscious. Most of our habits are unconscious, and in fact you could almost say the definition of a habit is that it's unconscious. We unconsciously do things like riding a bicycle. I mean, you get on a bicycle, and when you know how to ride it, you don't think about it at all. In fact, if you do, you might fall off. It just happens without you thinking about it. And when I'm speaking English, as I am now, I don't have to think about the words. They just flow. I don't know quite how, but they do. If I'm speaking Urdu, for example, which I can speak but not very well, I have to search. I speak slowly because I have to search my vocabulary, which takes time. I have to do it consciously, and so it's a very different experience. So even in our own case, you see, I think our embryological development is habitual. The morphogenesis is habitual, but it's not conscious. At least I'm not conscious of being an embryo and deciding where the liver should go and the spleen and that kind of thing. There's always so I think that the repetition of habits through morphic resonance is, generally speaking, unconscious. The instincts of animals, when they, I think, are inherited habits. And I don't think that when cats start purring or see a mouse and get excited about catching it, that it's necessarily conscious thoughts about catch. It's just kind of instinctive. And we have instincts too, like the eye blink reflex, or at least reflexes. If something comes towards your eye, you blink without thinking about it. So I think there's teleology in nature, purpose, but I don't think purpose necessarily has to be conscious. This, of course, all depends on how creativity happens in the first place, and that is the ultimate mystery, because how does the first feather or the first eye come into being? Darwin thought it was just by lots of tiny gradual steps, but there are certainly leaps in evolution, and we know most about human creativity because we're humans and we're creative ourselves, and we know creative people. And even if you ask really creative people, where does it come from? They don't really know. They just say, it came to me in a flash, or I suddenly had this idea. Or Mozart, for example, used to hear tunes in his mind and then just write them down. So you could say that creativity in the whole of nature does come from a conscious source, which could be God directly creating through conscious thought, but I think much more likely that it's delegated through different levels of nature. I mean, everything that evolves on Earth is within the field of the planet Gaia. That's within the field of the solar system. So there's always higher level systems within the field of the galaxy. There's always higher levels which may well have mind or consciousness within which creativity occurs. and it may just spontaneously spring up. As you know, Bergson, who you're interested in, as I am too, was very keen on the idea that evolution's made up as it goes along, rather than simply like projecting a film that's already there, and it's just a matter of projecting it in time. And so he didn't know how creativity works. I don't know. I don't think anyone knows how it really works. And it is mind-like in the sense that it selects among various possibilities. But I think we probably have to leave it as a mystery. But once things have been created, once new things have happened, they're subject to natural selection, and through repetition, bimorphic resonance become increasingly habitual. That's my hypothesis, but I leave the question of creativity open.
All right, super interesting. Yeah, so I'm definitely reminded of Bergson here and the way that Bergson sees like pure habit as just kind of mechanical repetition. And then consciousness is for Bergson, he sees it as kind of a way in which there's this broadening of the scope of influence in a way, rather than the habit just iterating itself. The organism is able to kind of reach into its own past, or even forward into future possibilities, and more actively navigate what's happening. And so, yeah, with habits themselves, once they've become fully solidified, then yeah, it seems like consciousness at the very least becomes much more diminished there. There might be some degree of kind of primordial, kind of bodily consciousness, but certainly not the kind of active, imaginative consciousness that we typically think of as associated with our moment-to-moment decision making. But even there, I would still say that for those habits to become less conscious or unconscious to begin with, there's still like a selecting that has to happen to begin with in order for them to become habits, right? Like there's got to be a distribution of possibilities and something, maybe not consciousness in our more everyday way of using that word, but something has to be kind of choosing there, unless it's just random, which I suppose is a possibility, though that I feel kind of a gut aversion to using an explanation like that, I must admit.
I agree. I think something has to be choosing, and I think that again, like Bergson and Whitehead, who we share an interest in both of them. Part of the role of consciousness is choosing among possibilities, and consciousness inhabits a realm of possibility, it seems to me, based on Whitehead's ideas. And the main role of consciousness is to choose among possible actions. And Bergson was very keen too on the idea that our perceptions and our thoughts are directed towards possible actions. They're not just pure perceptions for aesthetic reasons, they're action directed. Mm-hmm. So when I'm thinking about consciousness in non-human forms, it seems to me, if this is generally the case, it must be about, if insofar as animals are conscious, it must be to do with choosing among possible actions, which coexist in and the organism then chooses one. And this works along with instinct. For example, a bee has the instinct to collect pollen and nectar. And when a bee flies into a garden, there are all these different flowers, different colors, different shapes. So the bee is not consciously creating an instinct. I've got to go and get some nectar now for the good of the hive and to feed grubs and so forth. That's not, it's an instinct that's just happening. It's foraging for food instinctively. But it then has to choose which flower to land on and to collect it from. And it may be influenced by its previous experience of blue flowers with a particular scent, and it knows they're good ones to go for, or it may not. And it may then have to decide whether to go for the blue one or the yellow one or the red one or whatever. and all the different species. And insofar as the bee has a perception of the garden, a visual perception of the garden, and an odorant perception as well, because they can smell, then I think it would be conscious insofar as it's choosing among these possible actions. And I think this would be a general rule. I mean, I don't know if you've seen my paper on Is the Sun Conscious?
Yes, I have
Yes.
actually. Yeah.
Yes. Well, there, in considering the consciousness of the sun as part of a kind of panpsychist way of looking at nature, then if one asks, well, if the sun's conscious, what would it think about? Then on this general principle would enable us to at least guess what it might think about. And its thoughts, insofar as it's conscious, would be related to possible actions. So we have to think then what possible actions can the sun have? And one of them is firing out solar flares or coronal mass ejections. It's doing this all the time. Well, it does it more at some times than others. But then there's the direction when to do it and in which direction to point it, because if they're pointed towards a planet like Earth, they can have big effects. They can take out our power grids, for example. And if the sun really wanted to stop us in our tracks, all it has to do is aim a coronal mass ejection at the Earth, particularly when North America is sort of pointing towards it. It could sort of take out the most powerful economy in the world for months on end, because it would fuse all the transformers, and you couldn't fix them all because there aren't enough spare transformers to fix them all. You have to make them. And it would take months. The internet would go down. No one would see us on YouTube. All sorts of terrible things would happen. So the sun has possible actions that it can choose among, and I imagine that that would be one of the areas its consciousness would be directed to, the whole solar system and the way in which it can modulate what's going on within the solar system, which is in a sense its extended body.
Right. And it seems to me that insofar as the sun's consciousness may be making decisions for some kind of reason, it seems to me that that reason would have something to do with something like harmony or homeostasis or something like that, like maintaining the organization of the solar system, or even the sun maintaining its own place in the organization of the galaxy, for example, that maybe the sun is doing things to make sure it doesn't fly off into intergalactic space. And I think that there, in that consideration, there is kind of a hint, at least, as to what maybe some of the fundamental properties of creativity itself are. And Whitehead seems to suggest this. I certainly don't want to say that there's that creativity is something that we could just completely figure out, because I do agree that there is something deeply cosmic and mysterious about creativity. So I don't want to try and explain it away here. But at the same time, it seems to me that one of the fundamental dynamics of creativity has to do with taking multiplicities and synthesizing them into wholes, such that there's an overarching form that kind of weaves these differences together into something cohesive. And yeah, I can totally see how the consciousness of the sun, of the heliosphere, might be playing a role in doing that. It may have played a very significant role in actually giving shape to our solar system throughout our solar system's development as well. So yeah, so I don't want to drag us too far, because I know we do. I don't want to make this too long, but one other thing I wanted to bring up here, and so a lot of people, when I talk about morphic resonance, usually one of the first things that people ask, well, it depends. They're the people who are already fairly spiritualistic in nature, and they're like, "Oh yeah, we already knew that." And then there's the people who are more skeptical and scientific in nature. And the first thing that they ask is, well, then what's the mechanism? What's the medium, right? And this is interesting to me because what's implied there in that question is this idea that any kind of causation of any kind needs to be essentially things bumping into each other somehow. And if you're um, conjecturing any kind of action at a distance, then the question becomes, well, then what is mediating that interaction? Is it electromagnetic fields? Is it sound waves? Is it something spookier than that? And as I've explored these ideas, and especially the ways in which I've tried to connect the ideas of morphic resonance with Whitehead's ideas, and also the ideas of David Bohm, the conclusion that I've came to here is that there really isn't a medium and there doesn't need to be, because this kind of formative mental causation is actually prior to physical extensive interactions in the way that we typically think of the kind of physical composition of nature. And Whitehead comes to this conclusion, I think, in the exact same way in Process and Reality when he talks about his hybrid prehension, that mental feelings of possibility, that is to say, are not necessarily anywhere. They're not localized in space and time. And as such, interactions between them needn't be mediated by these kind of extensive spatial relationships. So, yeah, I just kind of wanted to put that forward and see what you think about all that.
Well, I agree. These are very important questions and very interesting ones. And I mean, I get asked the same thing too. What's the mechanism? How does it work? Mm-hmm. And indeed, I think about it myself. How does it work? Well, the first distinction I make is there are two real questions involved in my hypothesis. One is, how do morphogenetic fields or morphic fields in general work? Now, those are localized. My morphic field is within and around my body, and the morphic field of a rose bush is within and around the rose bush. So that's localized. And that, I think, works through patterning otherwise random processes. But there's the second question, the one you've been addressing, is how does morphic resonance work? How does information travel from past rose bushes to this rose bush, giving it the habits of rose bushes and of that particular variety of rose bush? And how does the human collective memory work so that we're all influenced by lots of other people in the past, with seemingly nothing in between? Well, when we come to that action at a distance in space and time, which morphic resonance involves, I think one thing to get this in context is to look at what science says about other kinds of action at a distance. I mean, gravity is the main kind of action at a distance that science was based on. Newton, found that argued that every mass in the universe, every massive body in the universe, attracted every other body in the whole universe, depending on the product of the masses and divided by the square of the distance. So there's a kind of universal interconnectedness through gravity, which was built into science right from the beginning in the 17th century through Newton's theory of gravitation. But Newton had no idea how it worked, and he thought that matter couldn't possibly attract other matter at a distance with nothing in between. So in the end, he started off by just saying hypotheses non fingo, that famous statement. I pretend no hypothesis about this. Agnostic. Here's how you can calculate it, but I don't know how it works. That was his basic position. But towards the end of his life, in the second edition of his book Optics, which is around 1720, he ended his life with a series of queries where he puts a whole series of they're not really about optics. They're all the unsolved questions and speculations that were in his mind that he wrote down before he died, the things that he knew he'd never have time to progress much further. And so his answer about gravitation was that the whole of space is the sense organ of God. Absolute space is the sensorium of God. And that's how God knows where everything is and what it's doing, because space is God's sense organ. And so God knows where every particle of matter is and how fast it's moving, and would then, through the divine will, coordinated it all. And gravity was, in a sense, basically the power of God, combined with God's knowledge of where everything was. Now, obviously, that's not the present explanation. I mean, when Einstein came up with his field theory of gravity, he said, well, there's a field that connects everything, the universal gravitational field, which is what contains the entire universe. Everything's within this field, and the field is not in space and time. The field is space-time, and that's what interconnects everything. But it's an invisible field. You can't see it. It operates across the entire universe. And in a recent discussion I had with Mark Vernon, we were discussing the speed of gravity. And as you probably know, Tom Van Flandern, a physicist, worked out that the speed of gravity must be at least 20 billion times the speed of light. That it might take 150,000 light years for light to travel from one side of our galaxy to the other, and that's just our galaxy. But it would take about a second for gravitational influences to travel that distance. Basically, physicists treat it as if it's instantaneous in their calculations for things like moonshots and stuff. So now, how is that working? How can almost instantaneous influence be spreading out from everything in the universe to everything else, connecting everything together? The gravitational field, Einstein thought no causal influence could go faster than the speed of light. But as Van Flandern shows, that's not how physicists actually proceed when they're calculating planetary orbits and stuff. They assume gravitation is basically instantaneous. And so what's the medium for that? No one has the faintest idea. And in the 19th century, when Maxwell came up with the idea of light as an electromagnetic radiation, he thought that it was carried by what he called the luminiferous ether, a form of subtle matter invented for the purpose of explaining the basis for light being transferred. But Einstein got rid of the luminiferous ether and just said, well, light just moves through the electromagnetic field. So then you say, well, what's that made of? The answer is it's fields all the way down. There's, in superstring theory, they say there's a superfield of 10 or 11 dimensions, or M theory has 11 dimensions, and that these were there at the prime moment of the primal origin of the universe, and then they get coiled up and compactified, I think is the term they use. And so electromagnetic fields are basically part of a 10 or 11 dimensional superfield. And, well, what's that? And then if you look at superstring theory, which is what about 80% of theoretical physicists work on at the moment with all these extra dimensions, then could some of those be involved in consciousness or morphic resonance? Well, the physicist Bernard Carr, who was professor of physics at London University and who worked with Stephen Hawking, thinks that these extra dimensions in physics provide a means for morphic resonance and for consciousness to work. But the thing is, David Bohm thought that morphic resonance could work through what he called the implicate order, and which was then folded out into the world we experience, which arose from his interpretation of quantum physics. So if someone says, well, what's the mechanism? I say, well, I don't know, but if you want to explain in terms of superstring theory, here's Carr's theory, and if you're going to understand it, you've got to understand incredibly complex mathematics. And David Bohm didn't really come up with the maths of the implicate order, but if he had done, it would have been beyond the reach of almost anyone who asked the question. So if people insist on that question, say, well, what's the mechanism? Insofar as anyone's proposed it, it's people like Bernard Carr and so or David Bohm. But if people are actually given the answer in terms of the equations, it wouldn't help them very much. Just as if they say, what's the mechanism of gravity? And they say, well, here's Einstein's tensor calculations. Even people in sort of graduate physics programs find it hard to deal with. So is that an answer? Or is it just a way of sort of blinding people with mathematics so they shut up and go away?
Mm-hmm.
So I think it would be possible to blind people with mathematics so they shut up and go away in the question of what's the mechanism of morphic resonance. But it still wouldn't really answer the question. And I think that there has to be some principle whereby things are connected through similarity across time. You used the phrase in one of your videos, morphogenetic space or morphological space. And in complexity theory, well, actually, the best model really is René Thom's, the French mathematician, his theory of morphogenetic fields, which sees them as attractors in what he calls a phase space, and so the morphic fields attract things into a particular pattern of organization within this multidimensional space. And the kind of space that his mathematics deals with has very many, numerous dimensions, dozens, hundreds of dimensions. So you can make models of these things in multidimensional mathematical space. But does it really help us very much? Again, it just blinds people with mathematics. But if one's going to have maths, I think his is probably one of the more promising lines. So basically, we don't know. And so when Faraday came up with the idea of magnetic and electrical fields, he didn't know how they worked. And his preferred view was that the fields were what he called modifications of mere space, rather than distortions of subtle matter, the ether. He didn't like the ether theory. He preferred the idea that matter was the basic reality was force, and force had patterns in space, and when it was sort of curled up, it gave rise to matter, which is much closer to the view that Einstein put forward. So Faraday didn't know. Maxwell said it's the ether. Einstein said it's just the field. And then in quantum electrodynamics, later development in physics, they say, well, all these quantum particles, including photons, have as a background the quantum vacuum field, which is not a vacuum at all, but is full of seething with potential particles. And in any electromagnetic interaction, virtual photons appear and disappear from the quantum vacuum field. We're both sitting on chairs right now, and the reason we're not going through them is our bottoms are repelled by the chairs, which stop them going through. And that repulsive force is electromagnetic, basically, and it's mediated by virtual photons, according to quantum electrodynamics. So under your bottom and mine, there's a vast host of virtual photons appearing and disappearing from the quantum vacuum field. Well, in that context of just regular phenomena like sitting on a chair, it's not as if science has an immediately obvious, intuitively clear answer as to how it's happening. And no one, by definition, has ever seen a virtual photon, since by definition they're unobservable. And yet they're the basis for explaining virtually everything we experience in everyday life.
Yeah, so there's all kinds of things to say about that, but yeah, I actually did see your conversation with Mark Vernon about gravity, and that was really interesting to me because what that seems to imply, as I see it at least, is that um, if we're making this kind of division between the physical, extensive on the one hand, and then something like what Whitehead would call the mental pole, or what David Bohm would call the implicate order, which I do believe are essentially the same thing when you really look at how those ideas fit together. What that then seems to imply is that gravity then is actually not really a physical force at all. It's somehow mental. It has to be, or otherwise, how would it be able to operate across space and time in that way? It seems to me that um, gravity somehow has to be conditioning um, how things relate to one another physically, but it has to be somehow coming from this implicate order, or this multidimensional morphogenetic space somehow. And of course, I am not a mathematician. I am not the guy with the walls of numbers to try and make sense of that to satisfy a physicist or whatever. But intuitively, it seems like that's the direction this is pointing in. And I feel like it's probably the same thing with light as well. Light is very strange and spooky, and that to me seems to implicate that light is also somehow bridging between these kind of mental and physical worlds somehow, though I can't tell you exactly how I think that works, but that's the intuition anyway.
Well, I agree. I mean, these are things I think about rather a lot at the moment. So just like you do, you see, I don't know if you've gone into the transactional interpretation of quantum mechanics at all.
I'm not familiar with that. No, sorry.
Well, I think it's a very big clue for what we're talking about now. It was put forward by someone called John Kramer, Cramer, who wrote a book on the subject and also shorter papers. And Kramer puts the view that, when light is emitted by something and absorbed, it's normally seen as going in just one direction. The sun emits light, and 8 minutes later, it's absorbed here on Earth, photons of light emitted by the sun. But Maxwell's equations for light have two solutions, the advanced and the retarded wave. One goes in the normal direction in time towards the future, from the past towards the future. The other goes in the opposite direction, from the future towards the past. And physicists are well aware of the fact Maxwell's equations can work both ways, but they say they just discard the so-called advanced wave because it's non-physical. Now, what happened is that Kramer took seriously Maxwell's thing, and he also took seriously an idea put forward in 1945 by Richard Feynman and John Wheeler, where they took up Maxwell's idea and basically came up with the idea that quantum processes involve this ambiguity. They can go either way in time. And Feynman later applied this to his quantum electrodynamics, where he argued that a positron, a positively charged electron, is exactly equivalent to an electron moving backwards in time. And Feynman diagrams, which are the basis of a lot of physics of particles, involve things moving backwards in time. Positrons are electrons moving backwards, and the arrows moving in the opposite direction to the normal causal direction. Now, Kramer took up these ideas from Maxwell and from Feynman and Wheeler and worked out a transactional interpretation of quantum mechanics, so that when the light from the sun leaves the sun, it takes 8 minutes to leave an atom on the sun and be absorbed by, say, a leaf of a rose bush in one's garden. So it's absorbed by a leaf in my garden right now. It's taken 8 minutes to get there, but at the very moment that it's absorbed, the atom in the rosebush that's absorbed it sends a kind of reverse or antiparticle of the photon to the sun, moving in the opposite direction. So by the time it reaches the sun, but it's been emitted 8 minutes after the sun sent off its photon towards the Earth. Now, the fascinating thing you see about this transactional interpretation is that it involves non-physical projection, and they're non-physical particles, but therefore they're working in a direction opposite to the normal physical causation, which is just what Whitehead thought that mental causation might do. Now, I got interested in all this because, as you probably know, I've been interested in the feeling of being stared at, the sense of being stared at, or scopaesthesia as it's called scientifically, scop, looking, aesthesia, feeling. When you feel you turn around, someone's staring at you from behind. It's a very widespread phenomenon. I've done a lot of research on it. It happens in animals as well as people. And is, I think, probably evolved in the context of predator-prey relations. An animal that could tell when a hidden predator was looking at it from behind would have a better chance of escaping than one that couldn't tell. And the response to this with animals and people is not consciously to think, gosh, someone's looking at me. It's without thinking, just to turn and look straight at the source. It's a directional phenomenon. My most recent paper on this is called Directional Scopaesthesia and its implication for theories of vision. If I'm looking at somebody from behind and they can feel me looking at them, there must be an influence going out of my eyes in some sense, which is what ancient theories of vision, including Euclid's, took for granted. And what Euclid argued in 300 BC is that when we see something, light comes in, but when we project out the images that we're seeing, and those images are projected normally to where things are. But if the light's come into our eyes through a mirror, it's been reflected from a mirror, our projection follows the light to start with, but then when the light's bent by the mirror, it being non-physical in the normal sense, it goes straight through the mirror. And so the images we see behind mirrors are called virtual images, and they're behind the mirror. They're our projections. Every time we look in a mirror, we're seeing our visual projections. The only difference is that when we're looking at things directly, the visual projections coincide with what we're looking at. I got onto this through chapter 1 of Bergson's Matter and Memory, where he discusses images and how images are projected. And he says, when I see something at point P, the image is not inside my head. It's at point P where it seems to be. That's how I got fascinated by the extended mind of the projection outward of visual images, and the sense of being stared at seemed to me an ideal way of testing this hypothesis, right? So it's not just an argument in armchairs, but if vision involves this outward projection, you can test it, and indeed I have done. So now, if there's an influence going out of the eyes in the opposite direction to light coming in, how could that conceivably work? Well, the transactional interpretation of quantum mechanics says, yes, every time something comes in, there's an emission of the opposite of a photon in the opposite direction. And that, if those are coupled and they're moving backwards in time, they're moving the opposite direction to the photons, if that's coupled to perception, consciousness, and awareness, then this puts us into a realm that's not far from the thoughts of Whitehead on the nature of minds. And so this has all been taken further by someone called Ruth Kastner, who wrote a book on the transactional interpretation of quantum mechanics, published by Oxford University Press. I mean, this is not some kind of fringe thing that's just in kind of obscure websites. I mean, this is... and she's actually in touch. In fact, she's going to a conference shortly with Matthew Siegel and others at Claremont, a Whiteheadian conference. She's, in fact, a Whiteheadian. And one of the things that Ruth Kastner says, which is utterly fascinating, is that in order for an atom to absorb a photon of light from a source, there's an offer wave and an acceptance wave. Kramer called it a handshake between the two, a handshake with the direction, they're both going in opposite directions at the same time, as it were. But in order to know which one to make the offer and the acceptance, there has to be, before that, something that happens faster than the speed of light, a realm of possibility, or what she calls potentia. Possibilities, a field of possibility within which this handshake between the emitter and the absorber happens, but it's preceded to know, they have to know where the different ones are that are going to enter into this transaction. And I think in a similar way, in gravitation, to come back to your initial point, there has to be a kind of knowledge of where everything is in the universe to respond to its force. So there's, and it's interesting that when Newton first put his idea forward, his great rival and arch enemy was Leibniz, the German philosopher. And Leibniz, his take on gravity, or at least the way everything's connected together in the universe, was that every monad, every self-organizing unit in the universe, has a mind as well as a body, and each monad, through its mental aspect, its consciousness, reflects the entire universe from its own point of view. So the whole universe is full of, everything in the universe is reflecting the whole of the universe from its own point of view. And everything has a different point of view because it's in a different place. And Leibniz also put forward something he called the principle of the identity of indiscernibles, that if two particles are in the same place at the same time, they're the same thing, and therefore they're not two different things. If they're indiscernible by being in the same place. What makes things different is by being in different places, and that gives them a different perspective or different knowledge of the whole of the rest of the universe. So consciousness was sort of baked into Leibniz's view of how everything interacts. It was also baked into Newton's, but instead of having it immanent in the particles, he had it in the mind of God. Now, I think that in gravitation, when Tom van Flanden's talking about this emission of gravity, the speed of gravity at 20 billion times the speed of light, I think what's being emitted could be some kind of something to do with knowledge, consciousness, potentia, or something of that kind. And here we're on the very edge of what's thinkable at present. But I think that the area you're talking about possibilities, potentialities, which comes so much in Whitehead's thinking, has this very interesting overlap with these aspects of these interpretations of quantum theory. And just one further point on this, the idea that there has to be something in between, how does it work and all that, is coming back to the point we were discussing. In quantum non-locality, two entangled particles can be miles apart. A change in one is instantly associated with a change in the other, which Einstein called spooky action at a distance. And there's nothing in between at all. So there's the spooky action at a distance is built into, is part of quantum theory. And what both Kramer and Kastner do in their transactional interpretation is show that this weirdness of this quantum non-locality is much less weird on the transactional interpretation, because the potentia and the offer and acceptance waves give you a whole new way of looking at it that makes it much less spooky. And so one of the advantages of their theory is they're able to reinterpret quantum non-locality in a way that's completely consistent, would be a natural consequence of their transactional interpretation. You have an astonishing ability to assimilate difficult ideas. There are bits of Kastner I don't understand, so I'm going to have to wait a few weeks until you've digested all this, and for your next 2-hour presentation on the transactional interpretation is going to save me a lot of work.
It'll happen. Yeah, yeah, this is great though. I definitely think that the common thread here that's connecting all of these is treating potentia as real things. I think that's really important because, especially if we're looking at this in a Whiteheadian way, the mental or noetic or whatever you want to call it is experience of possibilities, right? And so, as science, it's trying to contend with these weird phenomena by treating potentials as real things. And at the same time, it's having to deal with these ideas of like basically reverse causation, things kind of outside of time, determining the organization of time and whatnot. It seems to me like that's all kind of triangulating on this realization that there is what David Bohm would call an implicate order underlying all these things that we have to be able to make sense of in order to make sense of even very seemingly basic things like light and gravity or vision or sitting in chairs or whatever the case may be. So, all right. So, thank you so much for your time.
Well, just let me say one more
Yeah, go
thing.
ahead. Go ahead.
You know, when you said that potentia are real things, and that's almost an exact quote of what Ruth Kastner says in her book about potentia, and it is an argument that these possibilities are not just something non-existent, that they actually depend on what's happening in the world, and they're part of what's happening in the world. They're part of reality, and they help shape reality. It's much closer. I mean, it's almost word for word what you were just saying. So I do think there's a remarkable convergence, as you were saying, a kind of triangulation here.
Yeah, if she's a Whiteheadian, then I know exactly why she's saying that. Yeah, it's because that's the language that Whitehead uses, and yeah, I think it's absolutely crucial here. Because if you're just trying to look at things in a purely physicalistic way, only the physical and actual and discrete and measurable is real, then you just get so many things that just do not make any sense. And so I think that science, modern science, has had its toes in that mental realm for a very long time now. It's just they've been very reluctant to acknowledge that fact. So
Well, I think the Schrödinger wave equation, which is part of physics, is an equation which tells you all the possible things a quantum particle could do,
yep.
as Richard Feynman pointed out. And that equation is part of physics. It's not, it's about possibilities and probabilities, indeed. I mean, they're interpreted as probability waves. And the philosopher of science, Karl Popper, who you've discussed in some of your videos, called them propensity fields. So they're fields of propensity, which I quite like as a term. It's these possibilities, as in the Schrödinger equation, are part of quantum physics. And as you say, science has had its toes in this water for quite a long time. It comes in through quantum theory,
Yep.
and it's not going to go away. But the implications haven't really been thought out very well. And I think the transactional interpretation people who've been marginalized, just as David Bohm was marginalized within quantum physics, actually do something that in another of your videos you discuss how the inner sanctum of quantum theory is sort of separated off from ordinary people by being closed off to this inner priesthood. Only the inner priesthood who know higher mathematics can enter into the sanctum sanctorum at the ultimate mystery, and the rest of us are told not to think about it or just shut up and calculate or whatever. But I think that the transactional interpretation demystifies a great deal of this at the price of having so-called reverse causation or a polarity of flow, which is implicit in Maxwell's equations of light, right from classical physics itself. but when thought through, has so many implications, including understanding the nature of vision in a new way. Anyway, we've covered as much as we can in the available time today, but hopefully we'll have another chance before too long to go further.
Absolutely. I feel like we just kind of laid the groundwork for all kinds of things we could continue talking about. So again, thank you so much for your time, Rupert. Pleasure chatting with you.
The same goes for me. Thank you, Keelan.
All right. Have a good day.